Alright, so this is my latest video. It's on the powers of I. A quick reminder, I is defined as the square root of -1. And that really throws a lot of people off. Really, people try to say that this is just -1 or it's actually 1. But the problem is that there is no number in our real number system. So from -infinity to infinity, there's no number that when multiplied by itself will give you -1. In fact, there's no number that when multiplied by itself will give you a negative. Negative times a negative, those become positives. Positives times positives become positives. And 0, of course, multiplied by itself will give you 0. So it really confuses people that this doesn't have a value. But it really has no value in our real number system. So we created a whole new branch of mathematics dealing with what's called the complex number system. Now, complex numbers are things like 2i or 3 plus 4i. They're just numbers with this imaginary component. They can even be real numbers with an imaginary component attached to them. But I digress. This is about the powers of I and how to simplify expressions with I. So, the four main powers of I are I to the first, which is just I squared. Now, if we investigate that, that's saying -1, or sorry, the square root of -1 squared. And when you take the square root of something and then square that, you actually just get whatever's inside of this square root. So that just becomes -1. So this tells you that I squared and -1 are the same. Now I cubed, if we look at this, we can rewrite I cubed as I squared times I. I squared, we just found out, is -1. So this becomes -1 times I, or you can just write that as -I. And lastly, we have I to the fourth, which again, I'm going to break up like I did up here, using I squared. Because I squared is a nice number that I know how to deal with. It's a real number. So I have I squared times I squared. Okay, because when you multiply things with the same base, like I and I, you add the exponents. So 2 plus 2 will give you 4. But I squared is -1. -1 again. -1 times -1 is +1. Now, that means that I to the fourth is one of our favorite numbers. It's 1. We're going to use this fact and our exponent rules to rewrite all of the powers of I in relation to I to the fourth, or any power of I specifically. So I'm just going to take a general power. Why not I to the 13th? I want to rewrite that as I to the fourth somewhere in there. Well, if I had I to the fourth and then cubed it, I'd have I to the 12th. And I would need one more I on the end. This would give me I to the 12th times I to the first will give me I to the 13th. But I to the fourth is just 1. So this is really just saying 1 times I, or just I. Similarly, I can talk about, let's say, I to the 23rd. I want this to be some factor of 4, and then as one of my exponents, and then whatever's left. So I could get to 20 with 4, I to the 20th, times I to the 3rd, would give me I to the 23rd. I to the 20th can be written as I to the 4th, to the 5th. Again, I'm trying to rewrite all of these in relation to I to the 4th. So times I cubed. I to the 4th is just 1. To the 5th will be 1 again. So you're just left with I cubed. And again, I cubed, we notice, is just negative I. So I to the 23rd power is the same as negative I. And in fact, this leads to a nice little trick. For any exponent, let's say I to the n, in order to simplify it to one of these 4 forms here, you want to take n and divide it by 4, and what you really want to focus on is the remainder. It could have one of 4 different remainders. It could have a remainder of 1, a remainder of 2, a remainder of 3, or it could go into it perfectly, in which case there would be no remainder, or a remainder of 0. That would mean that this number, n, is a multiple of 4. If it's remainder 1, then your exponent here, your power of I, is actually just I. If it's a remainder 2, it's the same as I squared, which is equal to negative 1. Sorry, I'm crowding there. If it's a remainder 3, it's I cubed, or negative I. And if it's a remainder of 0, we can call it I to the 4th, or I to the 0. They would be the same, because they're both 1. Let's use this to kind of test out our theory on some larger exponents. How about I to the 66th? And we'll also deal with, how about I to the 121st? And I to the 576th. So I to the 66th. I know that 66, when divided by 4, will leave me with a remainder of 2. If you don't believe me, you can always do the long division. 4 goes into 6 one time. 1 times 4 is 4. Subtract a little bit, you get 26. 4 goes into 26 6 times. You get 24. And you're left with 2 down here, and there's nothing left to bring down. So 2 is your remainder. So I rewrite I to the 66th as I squared, or just negative 1. And this is the key point here, is that this big power is just negative 1. Let's see if we can do the same thing over here. So I'll take 4 and divide it into 121. So 4 into 1 doesn't work. 4 into 12, though, that's 3. Gives me 12. So I get a 0 here, bring down my 1. And that's my remainder, because I can't bring anything else down. So I have a remainder of 1. So, like I said up here, remainder of 1 just leaves me with I. So this big exponent of 121 is just I. So I to the 121st power is the same as I. Lastly, let's do 576. So we take our little division here, 576. 4 goes into 5 once. Leaves me with a 4. 1, 7 goes in 4 times. 16, 1, 6. Hey, that goes in evenly. Remainder 0. So that means this is the same as I to the fourth, or 1. So this I to the 576th power is just 1. That's amazing. And it lets us work with some very odd-looking expressions in order to simplify them. So let's look at, say, 3i squared plus 5i to the fourth. Now, this looks a little weird, and we can't combine any like terms because this I is squared and this I is to the fourth. But with our powers of I, this simplifies to be negative 3 plus this I to the fourth becomes I to the just 1. So this is just plus 5. So this odd-looking thing is actually just 2. We can do it with multiplication as well. If we have, say, 7i to the third times 6i times 6i, why not? 7 times 6 gives me a nice healthy 42. I cubed times I gives me an I to the fourth, because you add your exponents and there's an imaginary, get it? Imaginary I, haha. There's an imaginary 1 there. And I to the fourth is just 1, so this is just 42. You could also use your powers of I first before you multiplied. I cubed is negative I. So you could write this as negative 7i times 6i. Again, negative 7 times 6 is negative 42. I times I is I squared. But now, again, we have to deal with that I squared, which is just negative 1, which becomes, again, that positive 42. So really, the powers of I are used for simplifying expressions that otherwise look very complicated, and we otherwise couldn't simplify without investigating the powers of I in general. Well, thanks for watching.